Good morning, students. Today we shall be doing few problems on vectors. See, the problem is given. Prove that for a triangle sine a by small a equals to sine b by small c equals to sine c by small c, where ABC are the three sides of a triangle, and capital A, capital B, capital C are the opposite angles. So let's draw the triangle first. Let's draw the triangle first. And consider this triangle on the plane of the board, and these sides are vectors. That means vectors A, B and C. So this is vector A, this is vector B, and this is vector C, and these are the opposite angles. This is A, this is C, and this is angle B. Let's name them. So let's name the sides. Suppose E, F and G. And as per notation, you know that the magnitude of A is denoted as small a, magnitude of B is denoted as small b, and magnitude of C vector is denoted as small c. Now let's find the area of this triangle. How can you find the area of this triangle? So area is half magnitude of A cross B. Acha, how I come to the conclusion that area is half magnitude of A cross B? See, if you find A cross B, let's find A cross B. How do? You have already A vector, and let's slide B vector so that it becomes parallel to itself and it touches the same point where A originates. So this is the B vector, and let's make a parallelogram out of it. So this is the parallelogram, okay, and this is the V vector. Now the area of this parallelogram, EFG, let's name it as H. So it's basically a area of the parallelogram EFGH is A cross B. So this you know, right? Now, so half the area of the parallelogram, is this area of the triangle, because EG is the diagonal. Now if you expand this, this is half times A times B times sine of the angle between A and B. Let's name the angle. This is the angle, and this is the angle theta. Okay. Now what is the relationship between theta and C? So let's expand this EF line, extend this EF line a little bit, and we can easily identify that this angle is C, right? So we can easily say that theta plus C is equal to pi. So theta is equal to pi minus C. So here we can write half A times B sine of pi minus C is equal to half AB sine C. So this is this area of the triangle, EFG. Now if you go by some other way, let's find area of the triangle with the help of B cross C. So B cross C, what is B cross C? let's find B cross C. So here we have B, and you need C, right? C is already there. So what you need to do is you need to complete the parallelogram. So let's complete the parallelogram a little bit. Uh, Sorry. Here you have B. You must slide C, keeping it parallel to itself. Yeah, this is it, and this is it. So uh, suppose this is, wait a little bit, we are overlapping on this, so let's erase this a little bit. Sorry, let's erase this so that it doesn't become clumsy. You know that this magnitude of a vector A is smaller, so we need not explicitly mention. So let's now expand this, let's now slide the C vector, keeping it parallel to itself so that it touches where B originates. So this is the point, this is the C vector. Now join this two. Join these two. Let's name them. Let's name it. So from here, area of triangle EFG is basically half the area of parallelogram GEIF. Okay, so that is half magnitude of B cross C. Okay, now see, this is B and this is C, so let's mention the angle also. So take this angle as some different angle, which is phi, and we need to have a relation between phi and angle A. So what we need to do is we need to extend this FG line, okay, and this is angle A. This is angle A. So we can immediately say that phi plus A is equal to pi. Phi and A are in radians. So phi is equals to pi minus A. Okay. Now let's expand B cross C. So this is half BC sine phi is equal to half BC sine of pi minus A. So that is half BC sine A. So similarly, you can also show that the area of EFG. So similarly, you can show that this area, the same area, is equals to half AB BC CA sine B. Okay, now we have an equation like this, so let's write it. Let's write this equation. So let me write it here. I'm running out of space, so it's please pardon me for that. So I am taking it here. So half AB sine C is equal to half BC sine A is equal to half CA sine B. Now if you divide this whole equation by half ABC, so dividing by half ABC, so half AB cancels here, so you get sine C by A is equal to sine A by, sorry, sine C by C is equal to sine A by small a equals to sine B by small b. So this is the required proof. So this is the required proof. Yeah. So this is proved. So this is it. So I hope you understand this. Let's go to another problem. So let's do this problem. See, it's just an algebraic problem. See, A cross B whole square magnitude is basically, the problem is given, you can see A cross B whole square equals to magnitude of A square times magnitude of B square minus A dot B whole square. So let's expand this. A cross B whole square is A B sine theta, where theta is the angle between A and B whole square, right? So this you can easily write as A square B square sine square theta, which you can write A square B square 1 minus cos square theta, which you can write A square B square minus A square B square cos square theta, which you can write. So this is what? This is whole magnitude of A whole square magnitude of B square minus C A dot B. This is A dot B whole square. So A dot B whole square. See, in these problems, you please remember that these are written in bold, so these are vectors. I have not mentioned it explicitly. So keep this in mind, that these are vectors. Okay. Let's do another problem. See, this problem is very interesting. This is this problem we have done in geometry, but now we want to do this using vectors. See, a point A is situated on the circumference of a circle BC. Show that angle BAC is a right angle. A circle of diameter BC, show that angle BAC is a right angle. So first let's draw it. And let's draw the diameter. Okay, now suppose this is let me point the center. Suppose this is the center of the circle, this red dot, and suppose this is B and this is C, and let's mark any point, any arbitrary point. Suppose this point is A. Now join AB. Now join AC. So okay, you need to prove that angle. So you need to prove that this angle is 90 degree. You need to prove that, it's not given. Okay, So what we shall do is we shall join the center with A. Let's join that. And um, I should not mention, I should, let me draw this line properly. Yeah. Now I should mention that all the magnitudes, that means suppose if this center is O, so that is OB is equal to OA equals to OC is equals to R, radius of the circle, right? Now, how can you prove that BAB and AC, angle BAC is 90 degree? Very simple. Just take BA as a vector and AC as a vector and take the dot product. So that will help, right? So take AB as a vector, A to B. Suppose this is a vector and this is a vector, right? Take this is also a vector. It's very simple. So it's everything is originating from A. So we need to prove that AB dot AC is equal to 0. So if you can prove this, then automatically the angle BAC is 90 degrees. So how can you do this? So we have this, we need to prove this. So let's take AB dot AC. Now how can we write AB in terms of, we need to write AB and AC in terms of these AO, OB and OC. So AB is what? So AB is what? AB is AO plus OB. All are vectors, right? OC is also a vector. So AB we can write as AO vector plus OB vector. Okay? Dot AC is AO vector plus OC vector. Okay. Now AO dot AO is AO square, right? Acha. Let me explicitly write the terms first. Plus AO dot OC. AO dot OC plus OB dot AO plus OB dot OC. Okay. Now says AO dot AO. The length of AO is R, right? And AO dot AO is AO square. So I can write it as R square. Okay. Plus AO dot OC. AO dot OC. So leave it like that. AO dot OC. Leave it like that. Plus OB. OB dot AO. See, OB is O to B. The magnitude is R. So OB is basically minus of OC, right? So minus of OC vector. You understand that this OB is O to B and OC is O to C. So they are opposite. The magnitudes are same, both are R. So this is minus O dot AO, right? So let me mention explicitly, this term is this term, green. This orange term is this orange term. It's left like that. This pink term is this pink term. Okay? And the last term OB dot OC. See, OB and OC, they are opposite in sense, but the magnitude is the same. So OB dot OC is basically, what is the angle between OB and OC? 180 degrees. So this is minus r square, right? Magnitudes are r. Okay. So this will be, so r square gets cancelled, and so I can cancel this too, and these two terms, see, AO dot OC and minus OC dot AO, dot product commutes, right? So this is AO dot OC minus AO dot OC. So these two terms also cancels, so you get 0. So AB dot AC is 0. So that means, so angle BAC is 90 degrees. Okay.